Right triangle trigonometry. Here we're asked to use the given triangle, which is a right triangle with side lengths 8 and 15, to find the 6 trig ratios. We have the memory device Sohcahtoa there to help us remember that the sine is the opposite over the hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we need all 3 side lengths of the triangle, so we use Pythagorean Theorem to get the hypotenuse. This will be 64 plus 225 equals c squared. 289 equals c squared. And so we could leave c as the square root of 289. That happens to be 17, so I'll call it 17. Now when I go to write my trig ratios for sine, cosine, and tangent, I'll notice the opposite side to theta is 8. The hypotenuse is 17. The adjacent side is 15, hypotenuse being 17, and tangent is opposite over adjacent. Now to get the other remaining trig ratios, these are the reciprocals of the ones to the left. So the cosecant of theta is the reciprocal of the sine of theta. The secant is the reciprocal of the cosine. And the cotangent is going to be 15 over 8. So that's how we do this problem, where we're asked to find 6 trig ratios. Here we have another example. Again, the plan, we'll use the Pythagorean theorem to find that missing base, and then we'll use those 3 side lengths to determine the 6 trig ratios. Here's our Pythagorean theorem. We'll call the base x. So x squared equals 12, so x equals the square root of 12. And we'll just leave the base in terms of square root of 12. We do not need to simplify the radical. So now we'll remember Sohcahtoa, and we've got the sine is the opposite over the hypotenuse, 2/4. Another name for 1/2, but you can leave it as 2/4. The cosine of theta is adjacent, square root of 12, over the hypotenuse. And the tangent is the opposite over the adjacent, 2 over the square root of 12. Now, in class, you will remember that you learned how to rationalize the denominator. So you would need to multiply that fraction by square root of 12 over square root of 12. And your final answer would be 2 root 12 over 12, or square root of 12 over 6. The cosecant is the reciprocal of the sine. So 4 over 2, or 2. The secant is the reciprocal of the cosine. 4 over the square root of 12. Again, you're going to want to rationalize that denominator. The cotangent is the reciprocal of the tangent. Here we have an example where they're telling us the sine of 60 degrees is square root of 3 over 2, and the cosine of 60 is 1/2. And they're asking us a lot of questions about tangent of 60 and the sine and cosine of 30 degrees, which is going to be the complement, as well as the cotangent of 60. So let's start with our picture. And here we have 60 degrees. We know sine is the opposite over the hypotenuse, and so cosine is adjacent over hypotenuse. So now tangent of 60 degrees is opposite over adjacent. The sine of 30 degrees is the same thing as the cosine of 60 degrees. So that's going to be 1/2. The cosine of 30 degrees is the same thing as the sine of 60 degrees, so square root of 3 over 2. And the cotangent of 60 degrees is the reciprocal of the tangent of 60 degrees. Again, you would want to rationalize that denominator. That expression becomes square root of 3 over 3. Right, here we have a right triangle. We know the base angle there is 60 degrees. We're asked to solve for x, and so to simply get started, we want to write down what we know about the cosine of 60 degrees. That's one of the really important angles to memorize. The cosine of 60 is 1/2. We know that cosine is the ratio of the adjacent over the hypotenuse. So here's what I know. I know that whatever the hypotenuse is, it's going to be twice x. The sine of 60 degrees is the opposite over the hypotenuse. That doesn't exactly help. There's the picture for 60 degrees. Now the tangent of 60 degrees is the opposite over the adjacent, which if you look at the 60-degree triangle, it's the square root of 3 over 1. This will help because we can write a ratio. The square root of 3 over 1 is equal to, in the given picture, 32 over x. Now I can cross multiply and solve for x. And while that is the value of x, we don't leave our answer with a radical in the denominator. We rationalize the denominator by multiplying by a disguised form of the number 1. My new numerator becomes 32 root 3. My denominator is 3.